thank you. I think the, can you hear me? I think the Point Break thing says more about my age than my movie preference, but let's go with that. So, hi everyone. Thanks for having me. My name is Francisco, and I'm here to talk about a topic that I care about, which is how to manage software teams effectively. But more than that, I wanted to really talk about how I have approached that problem throughout my career, and kind of like how do I think about that as a framework. So to start, just like let's agree on something, and I think we're all here because of that. Like engineering leadership is complex, and it's complex because there are just too many things you can do. As an engineering leader, like there are like many challenges going around, and like to make things worse, no one is really telling you where to spend the time. So you come from being an engineer where you have a task in front of you all the time. As a manager, you just like don't have any boundaries. So should you spend today focusing on planning the next quarter, or should you read a design doc, or should you improve your one-on-ones, or think about that person who is not doing it that well in your team? These are all questions that you like are dealing day to day. So the question for me is always has been like how to simplify this, how to simplify engineering leadership in a way that I can manage it better on a day to day. So how do we make this practice something that's simpler to handle? And the answer is somewhat simple, which is like, for me, it's just like to think about it from a high level perspective. So how, like, if we step back and actually think from like a high level, like everything becomes a bit simpler to comprehend. So what is that perspective for engineering management? And for me, it is to view your organization, your team as a system, because any group of people trying to achieve a goal, together they are a system, right? They have inputs they are taking, they are producing something, and that's like their mission and their vision. So for a software team, for example, like of course the environments would vary, but they're mostly trying to produce something. And so like most software teams are trying to build a product to solve a customer problem, for example. So here's like my one hot take, which is that thinking in systems and thinking at high level will make engineering leadership simpler. So it will make it easier for anyone to understand where to act at any time. And here's a second hot take that I'm going to talk about today is that the system that people work also accounts for most of their performance. So it's really, thinking in systems is really a double win because it's simpler for you to understand what to do, but also lead to a better performance at the end. And these are the two things that I'm going to be talking about. So how to think in systems, how to make that decision making simpler, but also how to use that to help increase your team's output or performance. And being quite specific, three things I hope people come out of this conversation is one, an understanding of systems thinking. Two, how to apply to engineering leadership, so how you use it in practice in a team. But also like not only having a theoretical perspective, but having actually examples and practical things that you can take out like in your next week to your team. And we're going to be looking at that in 4 parts. So first I'm going to talk a bit about systems thinking, what it is, and kind of like how, kind of like level set what we're talking about. I'm going to talk about how to use it in practice, so how to think about that for a software team. Then we're going to go real practical with examples and like talk about some stories and kind of like some war stories about like using it in my career. And I'll finalize that with just like thinking about how to actually lead change in your team. And this is not so you actually come out of here not only knowing what to do, but with an idea what to do, but also an idea of how to actually implement it and the potential challenges you might face. So let's start this journey. So we'll start talking about systems thinking, and this is going to be a very brief intro. So for those who actually know the concept, like hopefully you don't get too bored. But let's go back to the source. So what is systems thinking? It's really like going to Wikipedia, which is where all the information is. It's kind of like looking at the whole instead of the parts. So instead of analyzing a problem by looking at each component of it, you're actually stepping back and thinking of it as a system and understanding how that system works. So brief history, like system theory is just like something that goes back to antiquity. So like we can look back into like just like any kind of like as long as you know history, there's like this idea of like thinking about systems and thinking about interconnections and like and contrasting that with the idea of like rationalizing a problem, which is just like building a problem from bottoms up. So system thinking is just looking from like top down. It has been used in multiple areas for like science, architecture, philosophy. So anything that you look, there's like influence from that perspective and the theory. And we're not going to go into like too much of a broad detail, but like one interesting turn that happens in this story is like with this person who is called Deming, and his work was very focused on system thinking for quality improvement and in production systems. So he's a US professor, but interestingly, he became quite popular in Japan, and Deming is considered to be one of the fathers of the Toyota production system. So like if you think about just-in-time, the pull system and all of that, these are based a lot on the ideas that Deming kind of came up or started talking about more. So if you ever drove a Toyota, you kind of like are reaping the benefits of system thinking in some sense. And then that also like getting closer to our industry, a lot of those principles from like Deming and from Toyota are obviously influences from like the iterative methodologies that have happened for the past decade. So like Scrum, Kanban, and any of these like iterative process that most of us use a version of, like they're inspired by those ideas. So going back to Deming, like one of the big kind of things he used to talk about is this idea that a system constrained individuals. So it doesn't matter how skilled, motivated, or talented someone is, if they work in an unproductive system, they will struggle to perform. So there's sometimes a confronting idea, and you might think that's not true. So I'll ask you to like go back in your memory and think about all those times that you've been in a place that you thought like, how can everyone be so incompetent in this place? And the truth is that they are not incompetent, but they are being constrained by the system they work on. So that their performance or their perceived incompetence is like pretty much a system shaping how they're working and how they can perform into that environment. But then, okay, of course, this is like a very like extreme example. You might think, okay, so that doesn't happen in software, right? Like we are kind of like, we have evolved past that. So I'm here to talk, I'm going to show you a brief example of something that's likely constraining your team today. This is a real example of a team that I used to manage, and this is kind of like 7 business days, and the dark areas are like when this ticket was, this is a life cycle of a ticket, so dark parts were like when the ticket was being worked on, like light parts is when like the ticket was waiting for someone to do something with it. So like went to development, then was waiting, then development again, was waiting a bit more, went to review, then waiting. And the gist of it is that this ticket spent more than 50% of this time just like waiting for someone to do something with it. So the work was kind of like stopped. So in this case, it doesn't matter how fast an engineer can code or how fast an engineer can review the code. Ultimately, the time it takes for the work to be done is mostly dependent on how the team is working and how much this ticket is waiting to be kind of like worked on. So again, going back, it's just like system thinking is about looking at the whole, like what is the end-to-end life cycle of this ticket instead of looking at the parts. So how fast can an engineer code, or how well can they code, like in a specific environment. Now, before we go any further, I want to like make a parenthesis, which is every time I talk about to people systems and processes, what comes to people's minds is something like this, right? Like we're gonna all become cogs in the machine. We're gonna like focus on the process, and it's gonna be start doing like these mindless tasks. They're gonna be just not productive, which is a valid concern because we all have been, I'm sure, in situations where like methodologies have been imposed and became like the set of rules that had to be followed at all costs, and kind of that becomes unproductive itself. So this is definitely not what I'm trying to sell here. Like the perspective that I'm trying to push or just talk about is just like not create a restricted system where people are constrained, but really creating an effective one where we take into account the individuals that are part of your team, the context that your team is in, to produce the best environment for them to work. We actually had a session, yes, I mean, we've been talking here like through this conference about how we have to manage different people differently, and this is all the same. Like you have to create a systems that actually takes into account the individuals that you have in it. So, okay, so we talk about systems thinking. So how do we use it in practice? How do we apply that into a team? And Going back to the beginning, like how do we think about your team as a system? And I think about like three main parts, right? So first, you understand your objectives. So what are your team's goals? How do you define success? And that was just like mentioned today in like the metrics kind of survey meeting about like how do you define success for your team? And I think that's the first part, the first question that you have to ask yourself. Second, once you do that, once you understand what the goal is, you can actually then inspect the work that your team is doing as a series of systems, a series of processes that are composed that kind of lead to that result. And after that, then like you know what the goal is, you know how the work works, and now you can actually start to actively manage and like focus on the areas that you need, on the bottlenecks of that system. So that's pretty much it. Of course, it's still a bit abstract, so we're going to look a bit more in depth about like how to do that. So first of all, why your team goals? I think that's a very broad question, and everyone's going to have like different perspective on that. But I'll share like my perspective and how I actually work with managers in my team. So we talk about two main objectives. One is a team should be productive, be highly productive, and continuously improve. So like a team should be delivering against their business objectives, like their mission or their OKRs or however you define that. And it should be always becoming better at that. So that's like the first level of success. The second one is that they should have engineers that are fulfilled and growing in their career. And of course, this is one, because we care about the people and we care about that they have a career that's like fulfilling, but also because you cannot run a team long term successfully if the people that are within it are not like being successful as well. Like at some point, you're going to have problems. So once you have the team goals, now you have to think about how your team works. You understand how the systems within your team, and this also, of course, will vary dramatically team to team and environment to environment. But they're probably going to fall into three main areas, which is product related. So there are systems to support the product delivery, the commercial goals of your team or the business goals. There are technical systems. So like how does your team actually deliver the software that they're building? And they're people related. So how are people working within that context? So let's look at some examples of that. So like, for example, in product, you might ask questions like, how does work go from idea to production within my team? So like, what's the process, who's involved? What is the life cycle of that? How is my team defining requirements? Like who writes them? How are they defined? Like how they're specified? Who's involved in the process? What is success? Like is your team focused on deadlines mostly? Or like that's like what success means, like hitting a deadline? Is your team focused on outcomes? They're all like systems that impact how product is thought. Within engineering, you can think about how iterations manage. Like do you set goals? Do you use estimates? How is that managed? How does an engineer actually get work from like kind of like from the, let's say, the to-do column to done? Like just like, do they collaborate with people? Do they pair? Do they actually write code by themselves? Like how is that process? How is your team verify quality? Like do you rely on automation? Do you rely on manual processes? Like who is involved in that? So again, these are all examples, but just like some of the examples of things that might influencing the result that you have. On the people, and finally on the people side, like what are the feedback loops for engineers? Like how do they know that their work is actually correct and good? How do they learn on the job? Like how do people collaborate with each other to actually learn? How do you have documentation? Do you rely on like kind of like just like informal learning? And then how does career growth work for people in your team? Like how they're reviewed, how they are kind of like get promoted and had performance reviewed. So once you do that, so now you understand both like what the goal is and how your team works, then you can act. So you say, okay, well, you can identify the bottlenecks and you can identify like what the problems, the bottlenecks to achieve the goals that you have. You can try to improve it and change it, and then you like, of course, measure results and continuously doing that. Of course, all these examples I gave before, they're all interconnected. So like you change something, it'll affect something else. So like this is a never-ending process, right? It's just like you're going to keep working and iterating on that. So we looked at what system thinking was. We kind of starting to look about how to apply it in practice, but that's still a bit abstract. So you might be wondering, like, how does it actually what we should actually be doing on a day-to-day, how do I use these concepts on a day-to-day. So I want to talk about 3 examples that kind of happen, some of them like multiple times in my career, and how I kind of use that perspective to kind of like get to a better result. So the first example is about team performance. And this happened when I joined a team, I joined a company a while ago, and like one of the teams that I was supposed to manage, or like was starting to manage, like was, my manager told me they are not doing very well. So, so the actual quote she used was like, the team must be demotivated, they might not understand their goals, like there must be some communication challenge. So in that context, the team wasn't performing well, so that was correct. And the symptom we were seeing is that they hadn't delivered their goals for like multiple sprints, and kind of like the features they were supposed to release weren't being released. So that was actually happening. And the kind of traditional path to like solution of that would be like, well, go talk to them and say, you know, you have to pay attention to the OKRs, or you have to put more effort, or like be like, you know, like take this more seriously, or kind of like just think about some motivational aspect of it, and talk about maybe the importance of deadlines for them. But instead of that, I decided to observe. I was new, so I kind of told the team, like, I'm going to spend 2 weeks just like seeing how you work. I'm going to talk to people. I'm going to go to the meetings. I'm going to like understand what was happening. And mostly I was interested in like, what are the blockers, right? Like, what's stopping work from being completed? And the result was actually the chart that I showed before. So that was the example. I had like, this was a real ticket that I took data from like GitHub and Jira, and like this was like kind of the life cycle of the ticket in that team. So so I went back to the team and said, this is what's happening, right? Like that's why we're not delivering, is because we're doing too much and people are just like not helping each other. Like this work is just waiting to be done. And the team actually at that point suggested changing a practice and doing like synchronous reviews. So like in practice, what we did was that we were in the office at the time. It was like pre-pandemic, so it was like if someone had to someone needed a code review, they could go and tap someone on their shoulder, someone else on their shoulder. That person had to stop what they're doing. They would come and pair on a review, and then they would like pretty much like fix the code together and like merge it, and that was done. And that was the only thing we did. And literally the next sprint, like that team delivered everything they wanted to deliver and achieve their goals, and that continued for a while. So really like what was needed at that time wasn't like a pep talk with the team and just like trying to kind of like explain to them like how they should work, but really understanding that the system they were working wasn't effective and how to change that for the better. The second example is about quality. So something that's probably quite common in a lot of teams. So a team I was managing at the time was having like significant quality issues. And in this case, the product manager that I was working with came with the suggestion of we probably should review our QA process, because of course, if we're finding bugs, that's probably where like the problem is. Again, like the symptom here was like we're having all these like bugs in production. They weren't like critical, but they were like happening enough that like customers were kind of losing the faith on some of our features. And the natural kind of suggestion for that was like, let's look at the QA process, because that's what we should do, I think. And but then like thinking about like a bit of the shifting left perspective, just like what we thought about doing instead was just like, let's look at the whole process and kind of feel about like how tickets were going from writing to being deployed. So like what was the life cycle of work in that team? What was the process was involved? How are the tickets written? And ultimately how the work moved like from end to end. And what I found was like this series of process challenges. So the way that the team specify requirements, that like the PM and the designer would like write them in isolation. They would just like define these tickets. They would then give to engineers that they would like break down the tasks in a bunch of technical work. So someone that was actually picking up the work to do, like they had little connection to what the goal was, and they just had this technical task to implement. And ultimately also like the person doing the QA at the end, it was really hard to understand what working or like passing QA meant, because like there was no connection to kind of like the feature. So in this case, what we did was like we actually changed how the team, like the process of writing tickets and defining requirements. We kind of involved engineering in that. We actually made the requirements specify behavior of the feature, so it was easy to QA and easy to test. And then with that, we actually solved a bunch of the quality issues, because at the point, like now, when a ticket was done or a piece of work was done, it was easy to understand if it was working or not, and that kind of reduced the problem. So again, like what was needed here was not more intensity in like, let's just like focus more on QAing, but just like thinking about how to change the system on the input side to make sure that like the process works better. And lastly, I want to talk about an example that actually happened a few times, which is talk about specific ones about like individual performance. And the gist of it was that I again was starting to manage a team, and I was told there was an engineer that wasn't performing very well, and what I was asked to do was like to performance manage them. So like really kind of like go talk to them and like, you know, give feedback, set standards, and kind of like ask for a change. So again, here we started with this engineer who's like not doing well, not performing. The symptom was like his work would take longer than much longer than others. The obvious solution was just like talk to them, give them feedback, and just like go from there. Instead, again, I was thinking about let's look at how the system works, right? And how does the team work? How does the individual contribute to the work in the team? What was the specific work they were failing at, and like that they had failed at, like from our perspective. And what I found was like in the team, like there was two things that were like really clear. Like the work was very poorly specified, so this person was like not tenured in the team. They were new, so it was really hard for someone that didn't know the code base and didn't know like the product to understand exactly what to do, and they kind of had when they picked some new work. Also, the team didn't collaborate much, so they didn't value a lot of like kind of like just like random interactions and questions. So it was really hard for someone new like this person to learn on the job, like to understand how to actually do something if they didn't know how to do in the first place. And that led to the individual struggling, which is like the kind of like the tragic but like funny part was that like they were actually like doing poorly because they were very eager to pick the most complex work for the team to prove themselves, but like that work was so hard to achieve in that context that they were like constantly failing at it. So in this case, what I did was like I just became more active in managing work for a while in the team. So that meant like being more active about like assigning who's going to work on what. Also to make sure that people understood what they're doing and they had no questions, understood the context of the work they're doing, and trying to make clear to the whole team that like helping each other was part of like making the team successful and creating a culture of that. That individual who was underperforming, I never gave them feedback at the end, and they became a very solid engineer and stayed in the company for many years. So again, like looking at the system, like was kind of help understand what the real bottleneck is instead of taking kind of this short-sighted perspective. So okay, so now we talk about systems thinking, we know how to use it, we know what the framework, we've kind of seen some examples. So everything should be easy from here now, but like. And in some ways, it should. I think it's simpler now it should be simpler to like think about where to act, but like in some ways it's not. And to close the presentation, I want to talk really about like where I see engineering leaders struggle when they try to improve their teams, and that's how to lead change in a team. So to recap, where what I talked about before, like once you know where to act, you should identify the bottlenecks, you should improve the system, and you should measure results. However, that can be challenging. Like leading change can be challenging, I think, for two main reasons that happen in practice. One is that it relies on a vision. It relies on someone having a vision of what the change is and what the result is, and it requires time. Like while like building, measure, and learn is true, you can do that, and you should do that as a cycle. In practice, it takes time for you to be able to, a lot of times when you're changing a team or a system, it takes time to be able to see the results. And in that process, someone has to be holding that vision together to say, like, this is gonna get to a better place at the end, and believing in it. Like looking a bit more in detail, that's because change usually looks like something like this. If you never seen this chart, is called the Satyr's change model. And pretty much what it says is that like things get worse before they get better. So when you try to change something, you're usually going to create confusion in your team. There's going to be some resistance because people are used to do something that way. There's going to be some chaos when people don't know what to do exactly. And then after you get to like learn the new habits, then you expect things to improve. So in that process, someone needs to like hold that process together and actually like take the team through that to that perspective. To make things a bit more complicated, I think it's team results are different than individual results, right? I think that's also a challenge that I think leaders face constantly, and team efficiency is different than individual efficiency. So I think as we looked at the example that I gave before, like I had to tell engineers that like it's okay for you to stop what you're doing and answer a question for your fellow colleague, because your output is not the main thing that we're talking about here. It's like the team's output, and that's so like you can slow down to like help someone else speed up. And the main challenge around this is that like a lot of our industry and many industries, of course, like are set up to focus on individual productivity. So it is, I've seen many times engineering leaders struggle to change teams because they are not holding a vision of how things should be, but they are following a path of least friction with everyone in the team. So I think, of course, that doesn't mean imposing something on others, but it means having the conviction of what you're trying to do and keep advocating and keep finding buy-in for that and keep like kind of pushing the right direction. So ultimately, I think about leading change in a team, there's like two things that I think managers need to believe in to kind of be successful at it. One is that building an effective job is the main job. Effective team is the main job for a manager. I actually haven't been the first person to say that in the stage since yesterday. So I think like, while like managers are not the truth holders or just like the person who knows everything, and they should collaborate with the team for that, but they are in a specific position. They have a vantage point that is able to focus on the whole team, while like most people can't. And also the second thing is to think that an effective team will raise all its members, right? So teams that deliver better will have people growing within it. People who work in effective teams will have more challenges at their disposal. So really kind of holding that thought and holding that belief is something that you have to kind of have to actually make to kind of help your team kind of like move forward. So to help with that, I think there's like three main principles that I think about when leading change. One is like the most important of all, like focus on team results over individual results. If you want a team that works well together, you have to, one, make them understand that the team results are better and more important than like their specific results. And you have then, of course, you have to value them like they're working together more than you value like them working individually. The second one is you need to be an expert on the work that your team is doing. So, and that's from beginning to end. So you need to, otherwise you might have a misguided view on like what needs to improve. So being meetings where they happen, pair with engineers, review codes, review docs, like the more you don't have to be, of course, like coding every day or being technical every day, but that doesn't have to stop you from being involved and knowing how like the work works in reality. And the third is just like lead your team towards results. Like, again, as a manager, as a leader, you don't have to own everything. You can delegate, you should collaborate with people, but you should own the outcome of that, and you should help that outcome be achieved and kind of drive that forward. So be active in steering your team every day. Ultimately, like every day is every day is a new play. You have to make sure your team has the best strategy for that day at all times. So that is all I had to talk about. So to recap, in order to create an effective team, you should understand your team goals and kind of define them in a way that like can allow you to have a high level on it. You should become an expert on the work. You should understand the work deeply. You should act on the system when you see and identify the bottlenecks to achieve those goals, and you should actively lead change. So you kind of should be proactive about like changing things for the better. Following this will make it easier to decide where to focus and also lead to better results. That's all I had. I hope you all were able to take these concepts and use them for the benefits of your team. Thanks so much for listening. I'll be around today, so if you want to chat more about the topic, I'm always happy to chat. Also, reach out via any of the links in the slides if you want to talk about it. And lastly, please watch Point Break. It's a classic, so I'll leave that with you. Thank you.